In this video, I'm going to talk about something in logic, which is the difference between necessary and sufficient conditions. And this video was motivated by this example, which is to write as an implication P implies Q. You can work here only if you have a college degree. And it's very tempting to identify P as you have a college degree and Q as you can work here, in which case P implies Q becomes if you have a college degree, you can work here. But this solution would be incorrect. It would be wrong. And the problem is that this solution implies that if you have a college degree, that's enough, that's sufficient qualifications for you to be able to work here. But it might be that you need a college degree and work experience. All this says is that you can work here only if you have a college degree, but it does not say that the college degree is enough. So the college degree may not be sufficient. And there are two reasons why I think this solution, which is wrong, is so tempting. And the first is that people often think of the then as kind of a timeline, like I get a college degree and then I work here. But it's not a timeline. The if-then statement is about what you can conclude. In particular is, if I know X, then I can conclude Y. We'll look more at this in just a moment. Other big red herring, and I think this is done intentionally to throw people off. It's the if here, if you have a college degree. People want to make that then the P because they want to make this the hypothesis. So you have to be leery of the if. Going back to the statement that the if then is about what you can conclude, like if I know X, then I can conclude Y. So looking back at this example, the thing is if you work here, then I can conclude that you have a college degree. So in other words, the P is you can work here, and the Q, what you can conclude is you have a college degree. So now P implies Q becomes if you can work here, then you have a college degree, which is exactly what this is saying. So this here would be the correct solution. Another way of saying this implication is to say that if P happens, Q always follows, or you might say Q necessarily follows. We can look at this in terms of one of my favorite examples for logic. P implies Q. The statement, if I am elected mayor, I will clean the streets, in which case this is P implies Q. If I'm elected mayor, then this is what will happen. So the thing you want to know is cleaning the streets is not sufficient for me to be elected mayor. In other words, it's not Q implies P. It's not if I clean the streets, I will be elected mayor. But cleaning the streets is necessary if I'm elected mayor because I've made this promise. If I'm elected mayor, I will clean the streets. So just to let you know, from this example, we know that the Q part is the necessary thing that follows P. So Q is necessary for P. And now if we go back to our college degree and you can work here example, again, the thing that's necessary becomes Q. So again, the college degree is not sufficient. So it's not college degree implies you can work here. That would be wrong. But the college degree is necessary. So it follows. So again, it's if you can work here, then I conclude you have a college degree. So that's it for this video. Thank you for watching.